Applications of linear functions. A scatter plot is a graph used to display paired data. A scatter plot is composed of numerous points, a, b, where a and b are numerical values representing two different events. Example A. The data in the table gives the height and shoe size of a group of 7 students. So we have each student's height and each student's shoe size. And here we've put shoe size on the y-axis and height on the x-axis. So one of the points here is 68, 12. So this point right there. Each of the 7 data points gives paired data, height, shoe size. In this example, there is a trend. Taller students tend to have larger feet than shorter students. Is this true for all of the data in our data set? It's not true of all of the points. For example, this point and this point, this person is taller, but their shoe size is smaller than this person. However, for most of the points, there is an upward trend like that. It's called a positive association. The relationship between the two variables in a scatter plot is called the association. There are 3 categories of association. Number 1, positive association. So like this. It occurs when the y values of the data points increase as the x values increase. Taller students tend to have larger feet than shorter students. Negative association occurs when the y values of the data points decrease as the x values increase. Example B. The data in the graph gives the number of days absent and GPA in math class for a group of 8 seniors. So the GPA goes down as the number of absences increases. This is an example of a negative association. Students who are absent a lot have lower GPAs. Number 3, no association. When there's no apparent trend that relates the two variables, there is no association. Example C. The data in the table gives the number of siblings and hours watching television for a group of 10 students. Here, this is an example of no association. From the data, there appears to be no correlation between number of siblings and hours watching television. The line of best fit, or trend line, is a line that best explains the data in a scatter plot. At this point in high school math, the line of best fit is a concept more than a process. A line of best fit can be computed using a calculator program or an online computer application. For now, though, we will draw a line through the data that goes with the flow, trying to have about half the data below the line and half above. Once your line of best fit has been drawn, you can determine its equation. This is called the prediction function. Example A. Look at the green segment, red segment, and blue segment in the dot cloud and decide which of the segments fits the data best. Alright, so we want about half the points to be below the line and half above. So here we have the green line, only 2 points are below it. 1, 2, 3, 4, 5 points are above it. So let's not use green. The blue line has no points above it. They're all below it. So blue's not going to work either. The red line has about 1, 2, 3 points above it and 1, 2, 3, 4 points below it. The red line is definitely the closest to the line of best fit. Alright, so then once we have our red line, we can figure out the equation for it using points on the line, like this point, and we call that the prediction function. In this case, p of x equals 0.46x, this is the slope of the line, minus 20.86. The y-intercept of this line will end up being negative 20.86, where x is the height and p of x is the shoe size. Example B. The data in the graph gives the number of days absent and GPA in math class for a group of 8 seniors. Find a prediction function p of x using the dashed line as an aid. So remember, p of x equals mx plus b. So we just need to solve for the slope and the y-intercept. So first, we'll do slope, then y-intercept. To determine the slope, we need to pick 2 points on the line. So we picked 2 points that are the easiest to see what they are. So for example, this point went right through 14, and it's about 71. And this point looks like it goes right at 3 and 90. So we use those 2 points to determine the slope. We have x1, y1 here, and we have x2 and y2. y2 minus y1, 71 minus 90, over x2 minus x1, 14 minus 3, gives us a slope of around negative 1.73. Determining b, well, we can extend this line and estimate what it is, but in this case, we just put we're putting the slope into point slope form, and then solving that way, we see that b ends up being 95.19, and here is our prediction function. Example C. Use the prediction function p of x to predict the GPA of a senior who misses 10 classes and 25 classes. We're going to use this formula here, this function. We're going to plug 10 into it and 25 into it. For 10, this is called interpolation because 10 is within the domain set. This is extrapolation because 25 is outside the domain set. For p of 10, we just plug 10 in wherever there's an x, which is one time here, and we get about 78. So does that make sense? 10, is this point at around 78? I would say so. And this one, p25, which we can't see on the graph, we can estimate to be about 52 because we plugged 25 into the function and that's what we get. And that makes sense. We can't see where 25 is, but it would be around here, and 52 would be around there. So yeah, this makes sense.